Hello and welcome back. So here we're going to be looking at solving quadratic inequalities. So the objective here is to solve quadratic inequalities by first finding what we call the critical values, and hence drawing a sketch to find the range of values for which the inequality holds. So a quick definition before we get started. A quadratic inequality has the form ax squared plus bx plus c, and it can be either greater than 0, less than 0. It can also be greater than or equal to 0, or it could be less than or equal to 0. The key thing is it cannot be equal to 0, because that would be an equation. So here's an example. So for this one, we need to solve x squared minus 5x plus 6 is greater than 0. So first thing we do here is we find what we call the critical values. So these are the values for which x squared minus 5x plus 6 is equal to 0. So to solve this, we need to factorise. So we think of two numbers that multiply to 6 and add to minus 5. So in this case, we have x minus 3 and x minus 2. So to solve this, we use the zero product property, so we end up with x equals 3 and x equals 2. So these are what we call the critical values of this quadratic equation. So now what we do is we sketch a graph. So we're sketching the graph of y equals x squared minus 5x plus 6. So I'm going to draw out the axes first. And I'm then going to label the roots. So the roots are when the graph passes the x-axis. So I'm going to label in 2 and 3 because I've just solved for the critical values. So I know that this graph here is a quadratic graph, and all quadratic graphs take the shape of a parabola. So this is going to be a positive parabola, so a U shape, because the coefficient of x squared is positive. So it's going to look something like this. So we're looking specifically where the graph is greater than 0. So in this case, we're looking where the graph is above the x-axis. So again, I should really label, so this is x and this is y. So we're looking where the graph is above the x-axis. So we're looking for these values here and these values here. So that the values of x for which the graph is above the x-axis are the values to the right of 3 and to the left of 2. So we can say that x is either less than 2 or x is greater than 3, because when x is less than 2 or greater than 3, our value of y is greater than 0. So here's another example. So again, we first need to find what is called our critical values. So our critical values are the values of x for which x squared plus x minus 12 equals 0. So factorising this, we have x plus 4 and x minus 3 equals 0. So now if we solve this, we end up with x equals minus 4 and x equals positive 3, and these are our critical values. So now what I'm going to do is I'm going to draw the graph of y equals x squared plus x minus 12. So I'm going to draw my axes. And I'm going to label my critical values. So my critical values here are minus 4 and 3. And it's again a parabola, so I'm going to draw a U shape like this. But this time we're looking where the graph is less than 0. So now we're going to be looking below the x-axis, because where it's below the x-axis, the y values are negative. So I'm looking specifically at the values of x between minus 4 and 3. So the answer to this question is x is between minus 4 and 3, but it can be equal to minus 4 and 3 because it's less than or equal to. So this is the answer to this question. Here's another example. So again, firstly, I'm going to start off by finding my critical values. So this time I'm finding the values of x for which 2x squared minus 7x plus 3 equals 0. So then I'm going to do 2 times 3 because this is non-monic, so I'm factorising a non-monic quadratic. So 2 times 3 is 6, and I'm thinking of the two numbers that multiply to 6 and add to minus 7. So here we have minus 6 and minus 1. And then I'm going to rewrite it as 2x squared minus 6x minus 1x plus 3. And then I'm going to split it down the middle and factorise both halves. So I end up with 2x bracket x minus 3 minus 1 bracket x minus 3 equals 0. And there we have 2x minus 1 and x minus 3 equals 0. So my critical values are x equals 1/2 and x equals 3. So now what I'm going to do is I'm going to draw the graph of y equals 2x squared minus 7x plus 3. So I end up with this thing here and this thing here. So my roots are 1/2 and 3, so I'm going to label 1/2 and 3, and I'm going to draw that U shape. So this time we're looking at the values of x where the graph is less than 0. So again, we're going to be looking below the x-axis. So I'm looking at these values here. So these are the values of x that are between 1/2 and 3. So I'm going to say 1/2 is less than x is less than 3, and that is the answer to this question. So here's another example. So we need to solve x squared plus 4x plus 1 is greater than or equal to 0. So this quadratic equation, if we try and solve x squared plus 4x plus 1 equals 0, unfortunately this does not factorise, so I'm going to have to use the quadratic formula. So subbing in the values of a, b and c, so a equals 1, b equals 4 and c equals 1 into the quadratic formula, I end up with x equals minus 4 plus or minus the square root of b squared, so 4 squared minus 4 times 1 times 1 all over 2, because 2 times 1 is 2. So it's minus 4 plus or minus the square root of 16 minus 4 over 2. So that's minus 4 plus or minus the square root of 12 over 2. So if I write these ones, so I have minus 4 plus the square root of 12 over 2, which is minus 0.268. And I have minus 4 minus the square root of 12 over 2, which is minus 3.73. So those are my critical values. So I'm going to draw the graph. So I'm going to label my critical values of minus 0.268 and minus 3.73, and I'm going to draw the graph. So this time it's greater than or equal to 0. So because it's greater than or equal to 0, I'm looking above the x-axis. So it's these values to the right of minus 0.268 and the values to the left of minus 3.73. So those are the values that are greater or equal to minus 0.268 and that are less than or equal to minus 3.73. So that is the answer to that question. So here's an exam style question. So pause the video if you want to have a quick go at this one, and I'll go through this answer in a moment. Okay, so the first thing we need to do is solve for the critical values. So I need to solve 3x squared minus 11x plus 6 is equal to 0. So I need to factorise this one, so it's non-monic, so I'm going to do 3 times 6, which is 18. So I need to think of two numbers that multiply to make 18 and add to minus 11. So that is going to be minus 9 and minus 2. So I'm going to write this as 3x squared minus 9x minus 2x plus 6 equals 0. Split it down the middle, so I have 3x, x minus 3, minus 2, x minus 3. So then factorising, we have 3x minus 2 and x minus 3 equals 0. And my critical values are 2/3 and 3. So now I'm going to draw out the graph of this function. So my roots are 2/3 and 3. And it's going to be a U shape. So we're looking for the values that are greater than 0, so the values that are above the x-axis. So in this case, the values above the x-axis are these ones and these ones. So it's the ones to the right of 3 and to the left of 2/3. So we're going to say x is greater than 3 or x is less than 2 over 3. Okay, so here are some quick-fire practice questions on this topic. Pause the video if you want to have a go at these, and I'll reveal the answers in a moment. Okay, so well done if you managed to have a go at those. So I've just revealed the answers. And yeah, so that's everything for this video. Thank you so much for watching, and I'll see you again in another video. Bye!